Okay, starting out filming for the sunset on the International Space Station. Of course, I don't have any control over the camera. I'm just doing a screen capture of the live feed, live stream. And if I switch over to this other screen here, you can see iss.astroviewer.net shows the International Space Station. It just crossed over a little bit of Mexico, and I think it's over Texas about now, and passing over North America anyway, over parts of the United States at the moment. Now, what you're looking at, if you look at the Earth there, it's going to be a little hard to make out any continents because the International Space Station is actually only about 254 miles above the ground. That's not really all that terribly high in terms of the size of the planet. So, you wouldn't see, for example, if you looked down at the North Pole from that distance, you wouldn't see the equator. The equator would be beyond the horizon, quite a bit beyond the horizon, actually. Let's see. Well, yeah, I guess I'll just wait this out. I'm not sure how much longer it has to go. It's going to be a while, actually. Hey, let me see if I can find something. I'm going to go into. Let's see. I'll just run a search here for Earth. Uh, RTH. Earth curve calculator, and see what comes up here. Well, I've got one I've clicked on before. I see that's highlighted. So let's see. Will that do for what I'm looking at? Yeah, I can make it do. Okay. Let's see. Target distance, eye height. Okay. Target distance. Is there a height of the imperial metric? Calculate. Oh, I see. It's how much. How much of, this is to show how much of something would be hidden at a certain distance. So no, that's not what I'm looking for. Let's see. Try this one. Earth curve calculator. Is that different? No, that's the same thing. Oh, here. Let's try it differently. Distance to horizon calculator. There we go. And distance to horizon calculator. Here we go. Another one I have clicked on before. Let's see. Observation height in meters in feet. Okay. Let's go calculator. And there are 5,280 feet in a mile times 254 miles. So we're looking at like 1341120 feet. So I'll do it that way. Okay, observation height in feet. Let's see, was that 1341120? Yeah, 1341120. Okay, so 1341120 feet. Calculate distance. So that's saying it's 1,441.5 miles to the horizon. Now, just to make sure I get an accurate number here, Distance from equator to North Pole. No, I didn't want that way. That's by road. Okay, try it another way. Distance from pole to equator. And that's showing 10,000 kilometers. Convert kilometers, 10,000 km to miles. So that's showing 6,213 miles from the pole, from either pole to the equator. And in comparison, the distance from the ground that you'd be directly above in the International Space Station to its horizon is only 1,441.5 miles. So you'd have to get higher up to make the horizon farther away, to see farther around the curve. So looking now, oh, I'm already in the dark area. Now, if you see that little where the red changes to blue, that's actually where it runs out of sunlight. Because don't forget, it's 254 miles up in the air. So when where the shadow hits the ground beneath it is not where the shadow hits the space station itself. And you can see the ground beneath it actually is dark. As would be expected. And the space station itself is lit. So, yeah, I thought the video might have been frozen for a moment, but no, it's not frozen. It's still going. Um, you might notice the beautiful colors there. Now, in what we're seeing on the horizon of the planet, you notice you're not seeing any bright red there. And again, we're looking from a much different angle than what you see on the ground. The red light is there somewhere. It's off the screen somewhere, but you can see that it is actually having an effect on the appearance of the space station, as some of that light reflects back up from the Earth. Um, but I believe most of the light that it's getting there is direct sunlight. Uh, I could be mistaken. Maybe it's out of the direct sunlight, and all it's getting is from the Earth. And looking at the shadow angles, um, it's kind of hard to tell. Um, no, okay, that little piece. Okay, there's a circle near a disc of some type near the middle. If you look slightly to the right of that, there's a sort of whitish cone area. I don't know the names of these things, but you can see the light is coming from underneath there very clearly, and that appears to be direct sunlight, but that also appears to be lit quite white, as opposed to the rest looks rather red. So uh, yeah, it's really hard looking at a picture like this to really get a feel for just how huge the disk of the Earth is. But if you can just look at the curvature that you see there and just try to figure out where the center of that circle would be, it's way, way, way off the screen. And so there is actually quite a bit of light reflecting from the planet onto the International Space Station. And that's gone into the dark. You can see a little bit of light left shining from underneath there, and I think that's actually that little bit of light left shining on the space station. I think is actually from that light that we're seeing on the horizon there. The little sliver of whitish light, which you can see is blocked by parts of the International Space Station. And now you might notice the whole frame has gone a little tinge reddish, and I think that's a camera artifact of a sort. At this point, I'm not really exactly sure quite how that works, but the camera is obviously set to adjust for the ambient brightness. That the brighter the image is, the less effective exposure time, if you want to call it that, it's given. Basically, to make sure that the image isn't overly saturated or overly dark in cases where there's reasonable lighting. Now, in this case, we're not at reasonable lighting anymore. It's down to there's almost no lighting at all, and the camera's trying, basically making the most of what little light there is to see. And I haven't talked to NASA about this. In the earlier video I made of the sunrise, I did mention I wasn't sure if it was on auto. I thought about it since then, and I rewatched the other video, and yeah, it's quite obvious that the camera is at an automatic setting, and that really makes sense if you think about it, because because as the International Space Station passes into bright daylight, and into darkness and through twilight areas, as sometimes they might want to change the direction the camera is facing, or the space station itself might get reoriented for one reason or another, and I'm not really sure. But the thing is, there's a lot of different conditions under which it has to be able to take a reasonable picture, get a reasonable image back. And so that automatic setting would make sense. So there's the position now over the Atlantic Ocean, and as you can see, it has gotten quite dark. There again is the distance calculator that I used. I'll make sure when I upload this that I keep it so that you can see the address bar. Hopefully it'll be clear enough if anybody wants to read the addresses off of these things, they can do that. And the distance from the pole to the equator, I ran the search there and got 10,000 kilometers, and that was actually done on purpose. And then that 10,000 kilometers converted to miles, so 6,200 or 6,213 miles, or 6,213.712, according to that calculation. And that's just from the pole to the equator. That's not the full circumference of the Earth. It's the circumference of the Earth is well, as you can see by that, it's a little over 2,400 miles in that direction. Around the equator, it's slightly larger than going around by the poles. Not a huge difference there. But that's 6,200, roughly 6,200 miles from pole to equator. The full distance from the pole to the equator, if you were, say, far enough to be able to see, looking straight down on the pole, to be able to see the entire equator, which of course you'd have to be infinitely far away to do that, and then it would be too small to see. But that would be the full distance, and here we're looking at roughly 1,400, 1441.5 miles. So Oh, 14 into 62. Let's see. 14 goes twice would be 28. 56. 60. 56. Um, so five times 14. No, that would be 70. So between 4 and 5 times. Um, so that's between 1/4 and 1/5 of the full circumference of the Earth that you're able to see as your horizon looking from the International Space Station. Of course, when there's enough light to actually see. Now, of course, the astronauts looking down at the Earth, they would have a better view than we do with this camera because they'd be using their own human eyes, which are better suited for such a purpose. But it's nice that we at least have something. Um, and so I guess that's it for this video. Thanks. Thanks for watching.